Hello friends, in the last lecture we studied regarding different types of cube, that is linear cube, circular cube, double-ended cube and multiple cube. So only we defined what are the different types of cube and we studied regarding the linear cube. Now in the today's lecture we start with the concept of with the new type of cube, that is a circular cube. But before start with the circular cube, here first of all we are discussing some drawbacks of linear cube. So we start with this. Suppose we want to insert a new element in the cube as shown in the figure. Even though there is a space available, the overflow condition still exists because the condition rear is equal to max minus 1 still holds true. Now we have to see the previous figure of linear cube, then we will understand what is the drawback of linear cube. So as we observe this figure 8.14, here front is equal to 2, rear is equal to 9. As two vacant space are available here, still we are not in a position to insert the data because the basic rule of a queue is that we are inserting the elements only from the rear end and we are deleting the data only from the front end. So as the space is available, it is of no use in the case of a queue. So to use this space which is available at 0th location and 1st location, we are using the concept of circular cube. Now here we have to understand that in a what manner we are using that vacant space. So for that we discussed that here in the figure rear is equal to max minus 1 means size of the element, size of the cube is full as all the elements are filled. As there is no element in the 0th location and 1st location, but there are some elements, or we can say that some value, or we can say that inside the memory there are some values are present. As the space is there, but it is considered as the queue is completely full because we are not in a position to insert the data. So rear is equal to max minus 1. Max means what? Total size of the queue. Total size of the queue is 10. So 10 minus 1 is equal to 9. Means rear is full. Rear is not vacant. At the 9th position, the element 72 is present. Means still we are holding the condition true of queue is full as there is vacant space. So this is the major drawback of the linear cube that I want to explain from this figure 8.14. So now to overcome this, what is the solution? So to resolve this problem, we have two solutions. First, shift the element to the left so that vacant space can be occupied and utilized efficiently. So if we are shifting the elements to the left hand side, as in the left hand side the space is available, so that we can use the space which is created at the right hand side. Means in the rear side the space is available, again the condition of rear is equal to max minus 1 is false and we can use that data. This is the first type, or we can say the first solution. Now the next one, the second option is to use a circular cube. The next option is to use the circular cube. Now in a circular cube, the first index comes right after the last index. Yes, this is very important. That's why I'm highlighting this point. The first index comes last. The first index comes right after the last index. So with the help of this, conceptually you can think of a circular queue like this. We can think of the circular queue like this figure 8.5. The circular queue will be full only when the front is equal to 0 and rear is equal to max minus 1. Means at the front no space is available, and at the rear side the queue is also full. So if the space is not available it is arranged in a circular queue, we can think of that the queue is full. A circular queue is implemented in the same manner as a linear queue is implemented. The only difference will be in the code that performs insertion and deletion operation. Now the second option is to use a circular queue. In the circular queue, the first index comes right after the last index. Means once the last index is over, right? Imagine the circular queue like in the figure 8.15. So that comes first nearer to the last index. So it becomes a circular queue. So that space whichever the created in the previous figure that is allocated to, we can insert the data. Now because that particular side is now the rear side of the circular queue. The queue will be full only when front is equal to 0 and rear is equal to max minus 1. A circular queue is implemented in the same manner as a linear queue is implemented. The only difference will be in the code. Okay, the only difference will be in the code of linear queue and the circular queue. In a linear queue, we are using different algorithms. In that, we have to consider the conditions of front and rear. Okay, and here also for the circular queue, we are considered the conditions of insertion and deletion. Okay, with respect to front and rear. So, in this figure 8.16, figure 8.17, and the last figure is figure 1.18. First example which explains the full queue. Second example explains queue with the vacant location, and third example explains the queue with the vacant location but at the front side. So it is joined as it is a circular queue. How we can use both the end of the queue to insert the data. Now, first example is the example of a full queue. Here, if front is equal to 0 and rear is equal to max minus 1, then circular queue is full as we discussed in the previous slide. Now in this figure of 8.16, total 9 elements are present. Front is equal to 0 and rear is equal to max minus 1. This condition is satisfied over here in the figure in the full queue. Total 9 elements are present. If consider rear is not equal to max minus 1, means as observed in the second figure, that is figure of 8.17, observe that rear is not equal to max minus 1. Okay, so this condition is true. As rear is not equal to max minus 1, total elements here are 9, and in the previous case total elements are 10, means one vacant location created. So in this case rear will be incremented because there is a space available and we can insert the data. Okay, that is only illustrated in figure 8.17. And in the third figure, that is figure of 8.18, in this figure, front is not equal to 0. In a front is not equal to 0 and rear is equal to max minus 1. Means at the rear side is full and front side is available. It means that the queue is not full because here now if we are considering the concept of linear queues over here, the queue is full, but as we are considering the circular queue, we are setting the rear is equal to 0, where we feel that vacant space is created as it is a circular queue, and then we are inserting the new element as shown in the figure 8.18. Okay, so we are set front as a rear. We are setting front as a rear in the case of circular queue because it is arranged in a circular manner. Last index, we are joining the last index to the first, to the front. Rear and front are joined together. That's why front is replaced by rear. Okay, and here also we are doing the same thing. As the vacant space is available, we are setting this position as rear and we are inserting the data in that particular vacant location. So this is the advantage of circular queue. So in the previous example, we are checking basic three conditions. First condition is front is equal to 0, rear is equal to, okay, observe the figure first. Front is equal to 0, rear is equal to max minus 1. In second case, that is queue with vacant location. In that case, we have to consider the condition rear is not equal to max minus 1. And in third case, we have to consider that front is not equal to 0 and rear is equal to max minus 1. Please understand these conditions because based on that conditions only you are creating the algorithms, and based on this algorithm you are creating the programs. So these conditions are very important to understand. So now what we are discussing that what is the circular queue, and in a circular queue what are the different conditions that we have to consider. So first condition we are considering that the concept of full queue. Now next is concept of queue with the vacant location. Third one is the if there is some vacant location is created at the front side, set rear is equal to 0 in that case and insert the element. Now see here what is the concept of circular queue. Actually we are using the space which is not able to use in case of a linear queue, as we can't what we can say mold it, or we can say we can't arrange the elements inside the memory. Or so this is all our what we can say, this is all because we want to understand the difference between the linear queue and circular queue. So in a circular queue we are write the conditions in a such a way that we can use the vacant positions. So here also, here only our aim is that whatever the vacant location, whatever the vacant position which is vested in the case of linear queue, that we are using in an efficient manner. So for this we are studied or we discussed regarding three conditions which we are dealing with. The first is the full queue. In that particular full queue, front is equal to 0 and rear is equal to max minus 1. So in that case, if this condition is true, then it represents that this is the full queue. And if rear is not equal to max minus 1, as explains in a figure 8.17. Now rear is not equal to max minus 1. Just imagine that rear side of the queue figure is in front of you. Rear is not equal to size of the queue, that is size minus 1. Size of the queue is 10, total 10 elements. So 10 elements in this queue, there are total 9 elements are present. One vacant position is there, so there is a chance of inserting the data at the 9th location. So we are increment the rear so that it points to the location 9 and insert the value there. Third one, in the third location, rear is completely full. Means as we are considering the condition that front is not equal to 0 and rear is equal to max minus 1. here this condition is true. Front is not equal to 0 and rear is also equal to max minus 1. But still, this is the limitation of linear queue. We are inserting the data in this condition also by setting front as a rear is equal to 0. So we are setting rear is equal to 0 and insert new element inside that particular location. So this is the advantage of a circular queue. Now in the previous lectures we also discussed the conditions, the various conditions of. Now this slide explains the three conditions, that is, if front is equal to 0 and rear is equal to minus 1, then queue is full. Then rear is equal to max, the rear is not equal to max minus 1, then the rear is incremented and the value is inserted. And third one, front is not equal to 0, rear is equal to max minus 1. It means that queue is not full. So set rear is equal to 0. So we are setting rear is equal to 0 as this is the first index which are arranged in a circular manner. Okay, and try to understand the concept. Imagine all the time that the queue is arranged in a circular manner. So the last come first, we are setting it is as rear, it is as 0, and we are utilizing that space. Now next, the concept of empty queue, the concept of queue with the single element. So here in this figure 8.20, front and rear, front is equal to rear is equal to minus 1. Whenever there is such a type of a condition occurs, or whenever such type of a condition is true, in that case we consider that our queue is empty and there is a chance of insertion of an element, right? See, in the case of a circular queue, only we are think of that whenever the vacant space is created. Whenever the vacant space is created inside the queue, we just have to utilize that space in what type and whichever algorithm where we can apply, we apply on that and we can use this vacant space so that the space wastage is not done with the help of circular queue. So see here, if front is and rear is equal to minus 1, then there are no elements in the queue, right? So an underflow condition reported. An underflow condition will be reported, right? So if the queue is not empty, now observe the second condition. In the first condition, the underflow condition occurs. In the second condition, the queue is not completely empty because front is equal to rear is equal to some value. At the 9th location, there are some values is present. So here we can see that value, that is the value is 81. Now see here, apart from all the locations are free, we can use that space. But if we are using here, in spite of circular queue, we are using suppose linear queue, then again this is a major drawback, right? Because here the vacant space is available but we cannot use that, as we are inserting the data only from the rear, and in the rear only one element is present, that is 81. Because of that only we made a conclusion that the queue is full. So in the case of circular queue here, our aim is to delete the element which is at the last, suppose in this case, and use the complete queue to insert the elements. So if the queue is not empty, front is equal to rear, then after deleting the element, as we are deleting, suppose we are deleting 81 from the queue, at the front the queue becomes empty. So the front and rear are set to minus 1, right? The front and rear, if delete this element, then set rear and front equal to minus 1, and there is a chance, or after that the complete queue is available to insert the element, right? So whenever we are studying the concept of circular queue, try to remember all the time that how to use a vacant space. This is only the important concept of circular queue here. Now, the next is queue with the single element. This is figure of 8.21. Okay, and the last one, the last figure, what it indicates, see here, at the 0th location up to 5th location. Now total 6 elements are there. From the 0th location up to the 5th location, total 6 elements. Total 6 elements are present. That is 72, 63, 9, 18, 27 and 39. After that, 3 vacant locations are created, and after that again at the end, 1 element is there at the last position. That is 81. So again in this case, what will happen again in this case? Queue is full, as we are considering the concept of linear queue, and again wastage of space. Now what we'll do that, again we are deleting the element at the last and set front is equal to 0. Again there is a chance to insert the element. If the queue is not empty and front is equal to max minus 1, then after deleting the element at the front is set to 0. So in such a manner, we are utilizing the space in the case of circular queue. So this is all about the circular queue. In this topic, we discuss what is circular queue and what are the different types of conditions that we are using to eliminate to use the vacant space. In a different manner, we can use the vacant space which is there, but we cannot access that as we don't have a sufficient algorithm to overcome the limitations. But in the case of a circular queue here, we are having some algorithms, some conditions. With the help of that, we can efficiently utilize the space. Thank you.